Hi, today I'm going to discuss about the topic RSA crypto system. RSA is named as Rivals, Shamir and Adelmans are invented the RSA crypto system, hence it is named RSA. The most common public key algorithm is the RSA crypto system. We have public key algorithms like elliptical, digital signal spread, Diffie-Hellman and RSA. In our syllabus, we have a detail about RSA crypto system. RSA uses two exponents E and D, where E is the public and D is the private. We have already said that the public key crypto system uses two keys. One is public and one is private, as compared to that private key crypto system. So here E is the public and D is the private. P is the plain text and C is the cipher text. Alice uses C is equal to P raised to E mod n to obtain the cipher text, and Bob uses the decryption side. Bob uses the plain text P is equal to C raised to D mod n, where E is the public and D is the private. The modulus n is a very large number is created during the key generation process. The main advantages of the RSA crypto system is the value of the n. If the value of the n is very large, the eve cannot attack the crypto system. Means the attacker cannot attack the RSA if the value of n is very large. If it is small, the attackers can easily attack the RSA crypto system. Encryption and decryption uses the modular exponential. Here in figure 10.5, the complexity of operations in RSA. Here the sender side, this is the receiving section. In Alice, the plain text P is equal to, during the encryption we are using the equation C is equal to P raised to E mod n, where E is the public key and we obtain the cipher text and it is given to the insecure channel. Here we have an attacker. Attacker need to, if attacker want to obtain the plain text, he need to calculate E of root C mod n. Exponential complexity. Next one here is the receiving section. Here the plain text is obtained by C raised to D mod n. Bobby uses the private key to obtain the plain text. D is the private key. The RSA uses modular expansion for encryption and decryption, that is P raised to E mod n, and in decryption side C raised to D mod n. And to attack it, E need to calculate E of root C mod n. That means the E need to calculate the root of C, E raised to root of C mod n, because it is very complex to calculate this value. So it is difficult to attack the RSA. And in case of the procedure, the encryption, the main three procedures: encryption, decryption, and key generation. In figure, this is the encryption side, that is the Alice side, and here the plain text is given, and the equation, by using the equation C is equal to P raised to E mod n, and the encryption we are using, and we are using addition and multiplication. That's the equation R is equal to Z plus comma multiplication, addition, multiplication, and we take the public key from both sides, that is E comma n, a tuple E comma n, and in receiving section we have the private key D, and the P is equal to C raised to D mod n. We can detail about the encryption and decryption ring. Encryption and decryption are done using the commutative ring. We are using two algebraic structures. One is ring and a group. The encryption and decryption are using a ring, and the key generation using a group. Encryption and decryption ring are done using the commutative ring. R is equal to S1 equal to Z1 comma addition comma multiplication. The two arithmetic operation, that is addition and a multiplication. And in case of key generation group, RSA uses multiplicative property, that is G is equal to Z of in comma multiplication and division. For key generation, we are using the multiplication and division, which is needed for generating the public and a private key. Next one is key generation algorithm. Algorithm is RSA key generation. Select two large prime numbers P and Q such that P is not equal to Q, where n is obtained by P into Q. Phi of n is equal to P minus 1 into Q minus 1. By using this equation, so we can obtain B is equal to D is the inverse of E modulo phi of n, that is E raised to minus 1 mod phi of n, and public key is n tuple E comma n, and private key is D. That is the key generation algorithm. Bobby uses the step shown in the figure to create his public and private key. After key generation, Bob announces the E comma n is his public key, and Bobby keeps the integer D as his private key. And in encryption, RSA encryption, P comma E comma n, the P is the plain text and E comma n is the public key. But we calculate the C. C is equal to P raised to E mod n by using the public key. Then we obtain the ciphertext. In decryption algorithm, same as that of here we have the key is private key, the private key is D, and this in decryption we have to obtain the plain text. So ciphertext comma private key comma enter. And we are calculating P is equal to C raised to D mod n and return P. These are the three algorithms are used in RSA crypto system: RSA key generation, RSA encryption, and RSA decryption. In RSA encryption, anyone can send a message to Bob using his public key. The size of the plain text must be less than that of the n, which means that the size of the plain text is larger than n. The plain text must be divided into blocks. In decryption, it's also same as that the size of the ciphertext is less than n. In RSA, P and Q must at least 512 bits, therefore n at least 1024 bits. If it is less than 1024 bits, the attackers can be easily attack the RSA crypto system. There must be n should be very large, at least 1024 bits or greater than 1024 bits. Then the attackers can attackers cannot easily attack the RSA crypto system. Proof of RSA. The encryption decryptions are inverse of each other using the second version of Euler's theorem. What is Euler's theorem? Euler's theorem means if P and Q are relatively prime, then it is where psi is Euler's torsion function for integers, that is the number of non-negative numbers that are less than Q and relatively prime to Q. That is P and Q are relatively prime, n is equal to P and Q. They have a torsion, psi is the Euler's torsion function. Therefore, using the equation is equal to P into Q, A is less than n and K is an integer, where A raised to K of I of n plus 1 is equal to A mod n. This is the proof. Here we have proof is that P1 is equal to C raised to D mod n. We have the equation C is equal to P raised to E mod n. We substitute that P raised to E mod of D mod n, then we obtain P raised to E D mod n. We use the second version K phi of n. We can obtain the equation P of mod n. Next, we have to discuss about the attacks on RSA. We have a figure. The main attacks of the potential attacks on RSA is that factorization attack, chosen ciphertext attack, encryption exponent, decryption exponent, plain text, modulus, and implementation. Factorization means we are using the value of modulus n. If the depending upon the value of n, the attackers can be attacked. In case of chosen ciphertext attack, that is a ciphertext only attack. Depending upon the ciphertext, we are using various steps to find the plain text. Then attackers can be easily obtain the plain text by using ciphertext. Then encryption exponent means if the value of the E is very small, then the attackers can be attacked easily. In the equation exponent is same like that of encryption exponent, depending upon the value of D. If the value of D is very less, the attackers can be easily attacked. And plain text attack, we have the attackers can have some information about some knowledge about the plain text. Then they can guess the characteristics of the plain text, and depending upon that characteristic, they can be obtain the full plain text, and then the attackers can be attack the plain text. In case of modulus, the same as that of that if a community, if a large number of senders using the same value of n, then attackers can be easily attack the value of n. And then the last one is the implementation. That is how we have to attack timing and power attack. That is here we have depending upon the time. The time required for encryption and the time required for the decryption. They calculate the time required for the decryption and then calculate the value of D, that is known as timing attack. In case of power, the attackers measure the power needed to decrypt the plain text and then decrypt the ciphertext and depending upon this power measurements, the attackers can be attacked. That's the main two attacks, timing and power attacks. We can explain it detailing. Factorization attack. The security of RSA is based on the idea that the modus is so large that it is infeasible to factor in a reasonable time. Bob calculates n is equal to p into q. To be secure RSA, n should be more than 300 digits, which means that the modulus must be at least 1024 bits. As already said that the modulus must be at least 1024 bits. Means the modulus n must be very large. Then the attackers, if a value of n is very large, n is very small, the attackers can be easily attacked. So p and q are 512 bits. So therefore n must be 1024 bits or greater than 1024 bits. Chosen cipher attack is a multiplicative, using the multiplicative property of the RSA ciphertext. You can intercept the ciphertext and using various steps so they can find the plain text P. Attacks on encryption exponent. We have already said that the value, depending upon the value of the E, to reduce the encryption time, the sender takes the value of the encryption exponent is very small. The value of the E is very small. The attackers can be easily attack the RSA crypto system. So the main attacks are the Coppersmith theorem attack, broadcast attack, related message attack, shortfall attack. And next one is the attacks on decryption exponent. This is same as that of attacks on encryption exponent. Here we have two cases: revealed decryption exponent attack and a low decryption exponent. It is obvious that if we can find the decryption exponent or even knows about, something knowledge about the decryption exponent, then can be currently encrypt the message. Next one is the low decryption exponent attack. Means here the value of the D is very small, then attackers can be easily find that. So the D must be greater or equal to 1 by 3 n raised to 1 by 4. 1 by 3 into n raised to 1 by 4. Next one, plain text attacks. We already know something about the plain text. The characteristics may allow some information about the plain text. Therefore, the main attacks are short message attack, cycling attack, unconcealed message attack. If you already know some information about the plain text, they can guess the characteristics of the plain text, and by using this characteristic, they can obtain the plain text. That type of attack is known as plain text attack. There are mainly three types: short message attacks, cycling attacks, and concealed message attacks. Next one is attacks on modulus. Common modulus attack means it can be launched if a community uses a common modulus n. If the value of the n can use a large number of community uses the same value of n. A large number of senders using the same value of n, then it is known as common modulus attack. The attackers can be easily find the value of n. Next one, attacks on implementation. That's mainly two types of attack: timing attack and power attack. In a ciphertext, this is a ciphertext only attack. You can intercept a large number of ciphertexts, that is CI to CM. Also, you observe that how long it takes for decryption. To decrypt each plain text, that is TI to TM, and then from these two values, from CI to CM, and how time take to decrypt the ciphertext, and it calculates all bits in D, that is D0 to dk minus 1. The algorithm used in here we have D0, and we have taken the time to decrypt the each ciphertext, and by using this timing and we have calculated the value of D. That's about the timing attack. Power attack is same as that of the timing attack. Here we measure the power to decrypt the ciphertext and obtain the plain text by using this equation. Next one, application of public key crypto systems. That's already we have said about RSA crypto system. Applications of public key crypto system, encryption and decryption. The sender encrypts the message with the recipient's public key. That's the main digital signature. Here the sender signs the message with its private key. Signing is achieved by a cryptographic algorithm applied to the message or to a small block of data that is a function of the message. What is digital signature? This is the figure of the digital signature process. Here M signing the process, verifying algorithm, M is the message, S is the signature. Here the sender uses a signing algorithm to sign the message. The message and the signature are sent to the receiver, that is M and S. The receiver receives the message and the signature and applies the verifying algorithm to the combination. If the result is true, the message is accepted, otherwise it is rejected. Both are true, then the message is accepted, otherwise it is rejected. That's about digital signature. Key exchange, two sets of cooperative exchange section key. Several different approaches are possible involving the private key or of one or both parties. Application of public key crypto system includes RSA, elliptical, Diffie-Hellman, and digital signature standard. Here, RSA uses encryption, decryption, digital signature, PSH. In case of in our module, we have to detail about the RSA crypto system that I already discussed about it. And in what are the requirements of public crypto system? We have already needed private key and public key. Is computation easy for party B to generate a pair of key, that is a private and a public key. PUB is the public key and PRB is the private key. Is computation easily for a sender knowing the public key and the message to be encrypted to generate the corresponding ciphertext. C is equal to EO. By using the message and the public key, the sender can encrypt the plaintext and they can produce the ciphertext. Is computation easily for the receiver to decrypt the resulting ciphertext using a private key to recover the original message. That same as that of we have to recover our original message by decrypting the receiver's private key. That is, in the receivers we have decryption for D and the PRB is the private key and ciphertext C. And D of PRB comma ciphertext means E of PUB comma M. And then substitute. It is computationally infeasible for an adversary knowing the public key. It is computationally infeasible for an adversary knowing the public key. And the main advantages of the public key crypto system is that authentication and integrity. If the Bob can be sent to the public key to the Alice, Alice must send its public and private key to the Bob. If it is verified, then only Bob sends the public key to the Alice. That's about the public key crypto system, its application and the requirements of public key crypto system. And we have today discussed about the RSA crypto system. Thank you.